All right, today we are going to start our introduction lesson on solving two-step equations in real-world examples. So today our real-world example is going to be the Kingdom of Montriarch. Here the ambassadors carry diplomatic pouches. The contents of the pouches are unknown except by the ambassador. Ambassador Milton wants to send $1 gold coins to another country. So you see we have our coins represented by this little yellow coin and our pouches represented by this little purple bag. So his daughter Sarah is a mathematician. She helps him devise a plan based on this word called equality to keep track of the numbers of $1 gold coins in each pouch. So each scenario has the same kind of thing going on. Each pouch contains the same number of $1 gold coins, and the number of gold coins on both sides of the equality sign is the same. However, some coins are going to be hidden in those purple pouches that we saw on the first screen. So let's try our first example to find the number of gold coins in each pouch. So here is our first example. So what we're going to do is each one of our coins is going to be represented by the number 1. It's just going to be a constant number. It has no variable or anything with it. The diplomatic pouch, we're going to assign it a variable because it represents an unknown number of coins. So I'm going to use the letter B to represent bags. So here's our problem. We have 10 coins on our left side, and then we have 3 bags plus 4 coins on our right side. So what I want you to do is I want you to put a number on top of each one of those gold coins. Remember, each coin is worth 1. So on top of each coin that I see on both sides of the equation, I'm just going to put the number 1 to help me remember that they're a constant, not a variable. So now I've got these 3 bags here that represent an unknown number of coins. So I said that my bags are represented by the letter or my variable B. So I'm just going to write the letter B above them. So let's write our equation. So over here, I've got 10 coins. So I'm just going to write the number 10. There's no variable or anything that goes with them because they're just coins, not bags. On the right-hand side, I've got 3 bags. So that means that I have 3 B's. So I am just going to write that as 3B. And then I've got 4 coins that don't have a home. They don't have a bag. They don't have anywhere. So they're just going to get tagged along with that B. So here's my equation. I have 10 coins, that equal 3 bags plus 4 coins. So what your goal is going to be to do is to get all the coins on one side and all the bags on the other side. So let's take a look. We have 10 coins over here, and we've got 4 coins on the right. It's always easier to move the least amount of coins. So I've got 4 coins over here, so I'm going to cancel those 4 out. So I'm going to put an X on each one of those 4 coins. Now remember from last week, what you do to one side, you have to do to the other side. So I subtracted 4 coins from here. So I'm going to subtract 4 coins from the left-hand side as well. So let's take a look at our equation here. So I have 3B plus 4. But if you take a look here, I got rid of those 4 coins. So the opposite or the inverse of adding 4 is to subtract 4. So I'm going to subtract 4 coins from the right. I didn't touch the bag, so I'm not going to worry about that. And then I also took away 4 coins from the left-hand side. So underneath that 10, I am going to subtract 4. So let's take a look on our right-hand side of the equation. Do I have any more coins on that side? Nope, they're all gone. So a plus 4, taking away 4 goes away. So all I am left with on this right-hand side here is my 3 bags. So I still have 3B. Over here, these 4 coins here are gone, so I'm left with 1, 2, 3, 4, 5, 6, 10 minus 4, which gives me 6 coins. So now we're down to a one-step equation. I have 6 coins equals 3 bags. So that 3 and that B are attached by multiplication. The inverse or the opposite of multiplication is division. So what I do to one side, I'm going to do to the other. So I'm going to divide each side by 3. So these 2 3's will cancel out. And I am left with 6 divided by 3, which gives me 2. So 2 equals B. Now remember, up here at the top, our B's represented diplomatic pouches, so let's write a sentence about our equation solving strategies. So we can say, in this case, we determined there was 2 coins per bag. Okay, so your challenge is going to be to try problem B. So here's yours, and I'm going to let you work on your own.